Download this code from codegive.com, link in the description below. Browser caching in ASP.NET Core, a comprehensive tutorial. Browser caching is a crucial optimization technique that significantly improves website performance and reduces server load. By storing static assets, like images, CSS, JavaScript files, locally on the user's browser, subsequent requests for the same assets are served directly from the cache, eliminating the need to fetch them from the server. This tutorial provides a step-by-step guide to implementing effective browser caching in ASP.NET Core, covering various strategies and incorporating code examples. Understanding cache control headers. The core mechanism for browser caching relies on HTTP headers sent by the server. These headers instruct the browser on how and for how long to cache specific resources. The most important headers are cache control. This header provides comprehensive control over caching. Key directives include public. The cached response can be shared by any intermediary cache, example CDN. Private. The cached response can only be used by the client and not shared. No cache. The response should not be cached. No store. The response should not be stored at all, neither by the browser nor intermediary caches. Max age equals seconds, specifies the maximum time, in seconds, the response can be cached. Must revalidate. If the cached response is stale, the browser must revalidate with the server. Max age equals seconds, similar to max age, but applies only to shared caches, CDNs. Expires. This header specifies an absolute date and time after which the cached response is considered stale. Generally, cache control is preferred over expires because it's more flexible and easier to manage. E-tag, entity tag, a unique identifier for a specific version of a resource. The server sends this along with the response. The browser includes the e-tag in subsequent requests, allowing the server to verify if the cached version is still valid. Last modified. Indicates the last time the resource was modified on the server. The browser uses this to perform conditional GET requests. Implementing browser caching in ASP.NET Core. There are several ways to manage caching in ASP.NET Core. 1. Using middleware ***. This approach allows for centralized caching control, applying to all static assets. We'll use a custom middleware to add the necessary headers. 2. Using response caching, for dynamic content. For dynamic content that changes less frequently, you can use ASP.NET Core's built-in response caching. This example uses the response cache attribute to control caching for the getData action. Adjust duration as needed. 3. Using static file handling, for static assets. ASP.NET Core's built-in static file handling already provides basic caching. You can enhance this by configuring the Use Static Files middleware. This approach leverages the onPrepare response delegate to modify the response headers for static files. Important considerations E-tag generation The calculate E-tag method in the middleware example is a placeholder. Implement a robust mechanism to generate unique and reliable E-tags based on the file's content, example using a hashing algorithm. Cache invalidation When you update static assets, ensure that the cached versions are invalidated. This can be done by changing the file name, adding a version number or timestamp, implementing a cache busting strategy in your client-side code, using query parameters, or using a CDN with efficient invalidation mechanisms. Security Don't cache sensitive data. Use no cache or no store for responses containing private or confidential information. Testing. Thoroughly test your caching implementation to ensure it works as expected and doesn't introduce unexpected behavior. Use Browser Developer Tools, Network tab, to inspect the cache headers and verify that caching is working correctly. By combining these techniques, you can effectively implement browser caching in your ASP.NET Core applications, improving performance, reducing server load, and creating a smoother user experience. Remember to adapt the caching strategies, duration, headers, to match the characteristics of your assets and application requirements. Prioritize cache control over expires, and utilize e-tags for efficient cache validation. Remember to handle cache invalidation to prevent users from accessing stale content.